Hey everyone, here is a presentation of the 8.5 notes on angles of elevation and depression and how we use those with trig functions. Some of you were out of class when we did these notes, so I'm posting this video for your reference. The objectives of this section are to use the angles of elevation and depression to find missing distances from a person to objects, and also to use those distances to go backwards and find the missing angles of elevation and depression. So first, on the vocab side, the angle of elevation would be from this bottom horizontal looking upwards to an object. And the angle of depression is congruent to that on that same scenario, and that would be going from the top horizontal looking back down. And you could see, if we just kind of highlight those horizontals, if these horizontals are parallel, then the angle of elevation and the angle of depression will be alternate interior angles and therefore congruent. Now, most scenarios in real life, these angles of elevation and angles of depression involve human beings looking up or looking down, and therefore it's important to note that that angle here would be from our eyes, from our eyesight, not from our feet, not from the top of our head, but from our eyes. So that's important here, and that's why I included that diagram. All right, let's look at how we use these in scenarios. In this case, example 1, Maria is at the top of a cliff and sees a seal in the water. If the cliff is 40 feet above the water and the angle of depression is 52 degrees, what is the horizontal distance from the seal to the cliff, to the nearest foot? Well, the angle of depression, 52 degrees, is from the horizontal, from AB here, not inside this triangle. So that's very important, and a lot of students have that misconception that they look at this angle as the angle of depression. So don't fall into that trap. The angle of depression is from the horizontal, and it will be congruent, alternate interior to this angle down here on the inside of the Z pattern. So 52 degrees, then you will have 52 degrees in here. So Sohcahtoa, let's take a look at what we know. We have, from the perspective of this 52 degrees now, the cliff height is opposite. And the distance, horizontal distance from the seal to the cliff would be adjacent. So we have this and this. So we are going to be looking at using the tangent because that's where we know the most information. Okay, so let's take a look at the tangent of theta equals the opposite over adjacent. And we have, in this case, the tangent of 52 degrees equals the cliff height over x, which we're trying to solve for. And we can cross multiply up, and we have x times the tangent of 52 degrees equals 40. And if I want to isolate x, I'm going to divide both sides by the tangent of 52 degrees. And we have x equal to, and we can calculate this out now with our calculator. We have 52 tangent, and I get a distance here. Let's see, they were looking for the nearest foot, so x equals 31¼ feet. So to the nearest foot, we would be approximately 31 feet. Now, some of you may have done this problem in a different way. Some of you may have looked at this complementary angle relationship up here at vertex A and seen that we can find a complementary angle to 52, which would be 38. So some of you may have looked at this in a slightly different way and said, the opposite of 38 is x, and the adjacent is 40. So you could have said tangent of 38 equals x over 40. That makes your algebra a little bit easier when you cross multiply. X equals 40 times the tangent of 38. and that is definitely a very valid approach as well. Okay, on to example 2. We have a gentleman, Vernon. He's on the top deck of a cruise ship, and he sees 2 dolphins following each other in the water. Vernon's position is 154 meters above sea level, and the angles of depression from his line of sight down to the 2 dolphins is 35 degrees and 36 degrees. So if you look at these angles of depression, I think the easiest thing to do is to think of the alternate interior angle relationships. And if we have 36 degrees here, then that's going to be alternate interior to this angle here, 36. And likewise, the 35 will be out here. All right, so we've got 2 different triangles here, and maybe it might make sense to just redraw them. We've got 35, and of course the height doesn't change at 154 meters, and we're going to look for this distance. And then we have 36 degrees, and again 154, and let's just call this distance y. So we're looking for the distance between those 2 dolphins, so we're really looking for the difference between x and y. And Sohcahtoa, always. Alright, from the perspective of 35 degrees, 154 is opposite, and x is adjacent. So we have tangent of 35 degrees equals the opposite over the adjacent. Cross multiply up, and we have x times the tangent of 35 degrees equals 154. And divide both sides by tangent of 35. And we have our distance x. So x is going to equal 154 divided by the tangent. My writing is messy up there. It's 35 degrees. And let's figure out what that is. That's a distance of, well, if I let's see, do I want to round up at this point? I'm going to not round up at this point. I'm going to say 219 9/10 meters. Now let's take a look at the next triangle. We've got the tangent of 36 degrees. Same thing, equals 154. It's weird. This should be 154. It looks funny. 154 divided by y, and we can cross multiply, and I hope you can follow the same approach. We're going to end up with the 154 divided by the tangent of 36 degrees, and we can figure out that distance. And we get y of 211.96, and if we take the difference between the two, and we round to the nearest meter, we are going to round up with that distance equaling 8 meters apart from each other. Okay, final example. Example 3, circus acts. At the circus, a person in the audience is at ground level watching the high wire routine. A 5'6" tall acrobat is standing on a platform that is 25 feet off the ground. Let's draw it. We've got a 25-foot platform, and we've got a person here. Obviously, my drawing is not drawn to scale, and that person is 5 feet 6 inches tall. If I put that entirely in feet, that would be 5.5 feet, because 6 inches is half of a foot. So this entire distance from the bottom of the platform to the top, if I add the two numbers together, I get 30.5 feet, 30.5 feet. Now we have a person down here at ground level looking up, and it's important to figure out where are they looking to. So how far is the audience member from the base of the platform? All right, so we're looking for this distance here. and that person is looking up to the top of the person's head. So we're going to go all the way up here. And we're looking for X. Well, from the perspective of this angle of elevation, which we're told is 27 degrees, from this perspective, we've got the opposite, we have the adjacent, and we have tangent. So tangent of theta equals opposite over adjacent, and tangent of 27 degrees equals the opposite to the top of the acrobat's head is going to be 30.5 divided by X, that distance we're looking for, cross multiply, X times tangent of 27 degrees equals 30.5, and we're going to divide both sides by tangent of 27. It's just a number. And finally, we have X equals this, and we can figure out what that is. We're going to take the tangent of 27 degrees, and it looks to me, now do they want us to round it? It looks to me, if I did everything correctly, I'm going to try this one more time. Looks to be 59.9 feet. So if we round that up, it's approximately 60 feet high. Or actually, we're not looking for how high. 60 feet distance to the base here. That's what we're looking for. All right, thanks for listening. I hope this helps. Take care.